So in this video, we're going to be looking at two special expansion strategies, the difference of two squares and the perfect square. Now, the difference of two squares occurs when we have one number plus another number, and then we have the same number repeated, subtract the same number repeated. So what I mean by that is if we had something like, well, x take 3 and x plus 4. Our a is x, and our plus b and minus b, plus b, minus b. So if you see this pattern, so these all follow the same pattern, the difference of two squares pattern, you can use this rule. Now, the rule is that we would have a squared take b squared. Now I'm going to explain the rule over here. So for argument's sake, say I had x plus 2, x take 2. And I wanted to expand this out, so I would use FOIL. So first, so x times x is x squared. Outers, x times minus 2 is minus 2x. 2 times x is plus 2x. And then 2 times minus 2 is minus 4. So, what happens? We have negative 2x and positive 2x. So these two terms just cancel out when we simplify them. They add together to give us 0. So we've just got x squared take 4. So, if we have the difference of two squares, a plus b, multiplied by a take b, we're going to multiply the a's together. So we're going to get a squared. And then we're going to multiply the b's together. And we'll have negative b squared. Because the middle terms cancel out. So, in a test, because tests can be under time pressure, so something like this in the test would actually only be worth 1 mark. So I'm not going to penalize you if you went x times x is x squared, and then x times 3 is 3x, and then minus 3 times x is negative 3x, and then negative 3 times 3 is negative 9. And then be like, oh, they cancel out, so I've got x squared take 9. I'm not going to penalize you for writing out that middle step, but in a test, this is only going to be worth 1 mark. So to save time, you need to be able to recognize this pattern. This is the difference of two squares, and you can jump straight to the answer. So for this next one, this is the difference of two squares. It's something, take something, and then it's the same number plus that number. So this is just going to result in 7 times 7, 7 times 7 is 49, and it's going to be minus x times x, which is minus x squared. So this is the difference of two square. And finally this last one, because the middle terms are going to cancel out. So we're going to have 3x times 3x, which is going to be 3 times 3 is 9, x times x is x squared. We don't need to worry about the middle terms, because they're going to cancel out, because this is the difference of two squares. And then we're going to have 4 times negative 4, which is negative 16. So that's how we use the difference of two squares to make our life easier. Now, the perfect square. Now, perfect square, realistically, this is just a plus b. So if I just use letters and numbers, so if we had x plus 2, all squared, really all that means is x plus 2 times by x plus 2. Because it's x plus 2 squared times by itself. And if we were to expand this out, we'll get x times x is x squared, x times 2 is 2x, 2 times x is 2x again, and then 2 times 2 is 4. And then we've got 2x and 2x, so they add together to give us 4x. And then 4. So, what we can do is, if we notice this pattern, x plus 2 squared, rather than writing it out and then multiplying everything, what we can do is, we can look at this, okay, we can jump straight to the answer. So we can go, well, it's going to be x times x, we already know that, so we can jump straight to x squared. And then what the rule is that we can do x times by 2 and then times by 2 again, because we're going to have two lots of it. So we can look at this and be like x times 2 and then double it. So 2 times 2 is 4, so it would be jump straight to 4x. And then 2 squared is 2 times 2, which is just 4. So when I'm expanding something like this, I jump straight to the answer. So something like this is only going to be worth 1 mark in your test, okay? But if you don't know what you're doing, you're wasting all this time. Now, so the formula for the perfect square is whatever this number is, squared, and then it's this number times by this number, and then times by 2. So it's plus 2 times by A times by B. And then it's B squared. Now, likewise, if it's A take B all squared, it's just going to be A squared, and then this times this and double it, so it'll be minus 2AB. And then minus B times minus B will just become positive B squared, because a negative times a negative is a positive. So this is the perfect square rule. Now, so the way that we use the rule is the following. So it's this one, it's our A squared, so it'll be X squared. And then it'll be this times this and double it. So it's X times 11 times 2 is 22X. And then it'll be this times 11. So 11 times 11. So it'll be 11 times 11 is 121. So very easily we can jump straight to the answer. Likewise for this one, it's just going to be this first number squared. So X squared. And then it's going to be this times this and double it. So X times minus 7 is negative 7X. Double it will give us negative 14X. And then negative 7 times negative 7 will give us positive 49. So last one, this will be 3x squared. So remember when squaring it, don't just jump to 3x squared. It's going to be 3x times 3x. So 3x times 3x actually gives us 9x squared. And it'll be 3x times 2, which is 6x, and double it. So 6x times 2 is 12x. And then 2 times 2 is 4. So in this video, we went through the difference of two squares and the perfect square rules. So in your test, these are only going to be worth 1 mark, and the time saved by doing it in one line is going to be the purpose. So in the future, you don't want to be writing out all of this. You just want to be able to jump straight to the answer. It's going to save you lots of time. So when you have a go at question 3 on page 154 in your textbook, let me know if you have any issues. Cheers.